controlling now the corrosion control, that is the control method mainly depends upon the factors such as type of structure, nature of the corrosion, the residual stress in the fabricated article, the nature of the environment, and the other factors that decides the corrosion. Based on that, we have to decide the corrosion controlling method. So major, there are four methods we adopted. That is a protective coating, use of corrosion inhibitor, cathodic protection, anodic protection. From this, I shall discuss a few points only, particularly the inorganic coating. Under that, the protective coating, we may come across an inorganic coating, particularly anodizing. Then under the second method, what we called it as a under protective metal coating. In that, I'll discuss the galvanization process. I'm not taking into consideration of this corrosion inhibitor or the anodic protection method, and directly I'll switch on to the cathodic protection method. There, I'll discuss the sacrificial anode method and impressed current method. So before that, I'll take the first method of controlling is a protective coating. The protective coating protects the metal from corrosion by acting as a barrier between the metal and the corrosion environment. Again, under protective coating, we come across three categories. The one, what we called it as a inorganic coating, the second one or metal coating, and the third one is an organic coating. The inorganic coating is a surface layer of metal. We usually convert it into their respective component by chemical or electrochemical. The one of the method of inorganic coating is a anodizing, or even the other method what we called it as a phosphating. Now I'll consider only anodizing. So this anodizing we usually define it is the process of developing an oxide film on the surface of the metal by chemical or electrochemical reaction. It is just we convert a metal into a metal oxide. It is a process of developing a oxide layer over the surface of the metal. Here we are not introducing any other metal. We convert a surface metal into the metal oxide by chemical or electrochemical reaction. Now I consider particularly the anodizing of aluminium. That is a conversion of aluminium into aluminium oxide, and called it as a anodizing of aluminium. Okay, so here in any process, controlling process, before carrying that one, either a chemical or electrochemical, we have to carry a pre-treatment. We have to decrease the components, that is if any oil or dust or a grease particle is present on the article, it should be degreased using organic solvent. Then it should be polished. If any rust particle deposited, it should be removed by polishing. And finally you may treat sulfuric acid. Then finally it should be washed with the water and added. Same way here also, while carrying anodizing process, the article to be anodized is degreased using organic solvent, thoroughly polished, then washed with water and air dried. So you may observe it is an electrolytic process. So here we'll take the two electrode, anode and cathode. So here the anode is nothing but an aluminium. That is article to be anodized or a coating or preventing the corrosion is taken as anode. Aluminium, that is article to be anodized is taken as anode, and some steel or copper is taken as cathode. Okay, it may be steel or copper that is taken as cathode. In an electrolytic bath contains here it should contain 10% chromic acid or sulfuric acid. You may take a mixture or individual acid. Okay, anode aluminium, cathode copper or steel, and electrolyte is a chromic acid. Then how much temperature you have to maintain? You have to maintain a temperature of about 30 to 40 degrees Celsius. And what is the potential you have to apply for process 40 volt? That time the current density developed is 10 to 20 million. When you apply a potential of 40 volt, the dissolution of aluminium take place. So Al3 plus ion is formed. It get oxidized to forming Al2O3. How? the aluminium interact with the water. So it interact with the water H2O. Okay, because here we take 10% sulfuric acid or a chromic acid forming aluminium oxide Al2O3, and along with the liberation of formation of H plus ion and electrons. As soon as the H plus ion is formed, and this H plus ion they migrate towards cathode. This H plus ion migrate towards cathode, and the same time the electron are migrated towards cathode through an external circuit. This H plus ion at cathode, the H plus ion takes electron and liberates hydrogen gas. So what is the net reaction you observe for during anodizing of aluminium? That is, aluminium interact with the water forming aluminium oxide. As soon as aluminium oxide is formed, they get adhered on the metal surface. It adhered on the metal surface. The surface layer of aluminium is converted into aluminium oxide, and the cathode reaction is a reduction. H plus ion reduced to and liberates H2 gas. Okay, liberation of H2. At anode, aluminium is changed to aluminium oxide, and the cathode liberation of hydrogen oxide. Aluminium get oxidized to aluminium oxide and deposited over the metal. The anodized coatings are thicker than the natural oxide film. So even if you keep the aluminium as it is in the atmosphere, a layer of aluminium oxide is formed by the oxidation process. But if you compare the film developed naturally with this electrochemical method, this electrochemical method film is much harder than the natural oxide film. So as a result, it improves the corrosion resistance as well as the resistance to mechanical injury. The article can be dyed by immersing in a solution of dye stuff at the 50 to 60 degrees Celsius, and further the corrosion resistance properties can be increased by the method called sealing, which involves heating in a boiling water. Finally, the article is treated with a nickel acetate. Yeah, aluminium get oxidized to aluminium oxide and get deposited. So if you want to introduce a colored, if you want a colored aluminium layer, then you can introduce a dye at a 50 to 60 degrees Celsius, and you may enhance the corrosion resistance property. This is one method of protecting. The other method of protective coating is a metal coating. You may introduce a particular type of metal over the base metal. There are two types of metal coating, that is anodic coating and cathodic coating. In case of anodic coating, the anode metal is coated over a base metal, whereas in case of cathodic coating, cathode metal is coated over the base metal. But the anodic coating is more advantage over a cathodic coating. That is, the anodic coating are produced by coating a base metal with a more active metal, which are anodic to the base metal. The important characteristic of anodic coating is that even if the coating is ruptured, the base metal does not undergo corrosion. Here, we'll take a metal. Here this is a base metal, and this base metal act as a cathode, whereas the coating metal, here we introduce a particular type of coating metal, and this coating metal act as anode. Even this rupture of this coating metal is observed, but the exposed portion of the base metal is cathode with respect to the coating metal, and thus it will prevent the corrosion. Even it is ruptured, the base metal does not undergo corrosion, as the exposed surface of the metal is cathode with respect to base metal. Okay, and one good example for anodic coating is galvanization. Okay, the metal coating can be applied on the base metal by hot dipping process. This method is used for producing a coating of low melting metals. It is particularly applied for a low melting metals like zinc, aluminium, tin on iron or steel metal which have a relatively high melting point. That is, a base metal is like a iron, whereas coating metal may be a zinc. Okay, and the process example may be galvanization or tinning. I'll take only galvanization process. It is a process of coating zinc metal. Here coating metal is a zinc on iron or steel by hot dipping process. Okay, a process of coating of zinc metal on iron or steel by hot dipping process. So it can be summarized this way. So here we have to take a sheet of iron, and that iron sheet should be first, it should be pre-treated. We have to remove all extraneous matter. For pre-treatment purpose, the iron sheet is first immersed in a immersed in an organic solvent in order to degreasing process. Here, degreasing of component take place. Degreasing with organic solvent. Then iron sheet is passed through a dilute sulfuric acid to remove any rust or oxide deposit. In order to remove rust or oxide deposit, it should be passed through dilute sulfuric acid. Then, after introducing organic solvent and the dilute sulfuric acid, if you directly subject it into a galvanization process, then H plus ions present in the sheet help for reduction reaction when you expose to the atmosphere. To prevent that one, it should well wash with the distilled water. That's why to washing purpose, it is immersed in a distilled water. Then again, in a basic medium, if hydroxyl ion is present, then again the corrosion take place. So that's why it is then passed and then it is dried. Okay, first it is washed with organic solvent, then dilute sulfuric acid, then we are washed with the distilled water, then passed through a dryer. Then the iron sheet is dipped in a molten bath of zinc, maintain a temperature of about 420 to 430 degrees Celsius, covered with ammonium chloride flux in order to prevent the oxidation of, this is introduced to prevent the oxidation of zinc, to prevent the oxidation of zinc. That is, the iron sheet is dipped in a molten zinc covered with ammonium chloride flux, which prevents the oxidation of zinc metal. Then, so here it's just a dipping process. The thickness developed on the surface is not uniform. So that's why to make a uniform thickness or in order to absorb the excess coating, the metal is removed by passing or it is passed through a two hot rollers and cooled gradually so that the uniform thickness is developed. Okay, we can summarize this way. The iron sheet is subjected to pre-treatment by degreasing the organic solvent. Then the sheet is passed through dilute sulfuric acid. Then it is passed through dilute H2SO4, dilute sulfuric acid at 60 degrees Celsius to remove rust and oxide layer, washed with the distilled water and dried. Then iron sheet is dipped in a molten bath of zinc at 425 to 430 degrees Celsius, covered with ammonium chloride flux, which prevents oxidation of zinc. Then excess of coating of metal is removed by passing through a hot roller. The main advantage of coating in anodic nature, the exposure of base metal will not cause any corrosion. The disadvantage of this is galvanization is since here should not be used for preparing and storing foodstuffs. Since zinc dissolves in dilute acid produces toxins, so that's why it should not be used for food preparing and storing purpose. Okay. It is mainly used for galvanized steel reinforcement or used for building construction where a high degree of corrosion resistance is required. In making of roofing sheets, buckets, wire, pipelines, even in the manufacture of mobile parts, the iron metal is subject to galvanization process. Another type of metal coating, what we call it as a tinning, it is a coating of base metal with the noble metals like a tin, particularly in the process of coating of base metal with a tin, called it as a tinning process. The next method of protection of metal is by cathodic protection. The basic principle involved in the cathodic protection is eliminating the anodic sites. The metals undergo corrosion due to the formation of electrochemical cells. Thereby, flow of electron takes place from anodic to cathodic region. The anodic region undergo corrosion whereas cathodic regions are unaffected. That is a known thing. The corrosion can be prevented by the cathodic protection. In the cathodic protection, can eliminate the anodic side when converting the entire metal into the cathodic side. The principle involved in this method is to convert the corrosive base metal into cathode, that is entire metal surface into cathode. So by eliminating the anode side, we can able to protect the metal, and this method what we called it as sacrificial, this method what we called it as a cathodic protection. Under cathodic protection we come across two methods: sacrificial anode method and impressed current method. In the case of sacrificial anode method, it is the protection of parent metal from corrosion by converting it into cathode by connecting it with a more active metals like magnesium, zinc, aluminium, etc. Here, I want to protect this steel pipe. So, I'll connect the steel pipe, or nearby steel pipe, I'll introduce a more active metal like zinc or even magnesium. Okay, so it is a protection of the, I'll consider the steel is a parent metal, protection of parent metal from corrosion by converting this metal, entire metal, into a cathode by connecting with a more active metal, and that connected metal act as a anode. So if you connect this metal, so it act as a anode, whereas this one act as a cathode. So you know anode only undergo corrosion, cathode is the does not, or it protected from parent metal structure. Okay, the more active metal so employed is called as sacrificial anode. Okay, the more employed or the sacrificed in order to protect the parent metal. The metal to be protected is converted into cathode by connecting it with a more active metal which acts as an anode. The more active metal gets corroded while the parent structure is protected from corrosion. The more active metal so employed is sacrificed to protect the parent metal. The method is known as sacrificial anode. That's why anode sacrificed in order to protect the parent metal. The sacrificial anode should be replaced by fresh one as and when it is required. So it continues. Anode undergo corrosion. Zinc is lost in the form of zinc ions. When all zinc metal or the zinc is lost in the form of zinc ion, it should be replaced with the fresh one. And commonly used sacrificial metal is a zinc, magnesium, aluminium, etc. Most common is a zinc and magnesium. The example is steel pipe being protected by connecting it with a block of zinc. In such a cases, steel acts as a cathode and is unaffected or protected from corrosion, but zinc acts as anode and undergo corrosion. Uses it is used to protect the buried pipelines, ship shell, underground cables, water tanks, etc. The other type of cathodic protection, what we called it as an impressed current method. In the impressed current method, a direct current larger than the corrosion current is applied. So you can see here, I want to protect this metal. So I want to protect this metal. So see, this may be some iron metal. If I want to protect this metal, so I should connect another inert anode, and I'll apply a potential, a large potential, which is larger than the corrosion current. So if you keep these two metals together, the iron metal may undergo corrosion, or due to the formation or presence of some extraneous metal, anode and cathode is formed. So as a result, corrosion takes place. So it develops a small corrosion current. So if you apply a DC potential which is larger than this current, then the entire site act as a cathode because it is connected to a cathode terminal. And the method what we called it as impressed current method. In this method, a direct current larger than the corrosion current is applied. The metal to be protected should be connected to cathode terminal of the battery, and it acts as a cathode. It is connected, the metal to be protected is connected to cathode terminal of the battery and act as a cathode. An inert electrode is connected to anode source. Mainly used inert is a resin bonded graphite or a silicon iron alloy, etc. That metal act as an anode, since the anode is inert in nature and it is unaffected. So we can summarize this way. So in this method, the anodic base metal, which is oxidizable in corrosion reaction, is supplied with the electron. The current is applied in the opposite direction to nullify the effect of corrosion. That is, through a small current flow by means of a battery, so that oxidation is suppressed and the corrosion of the base metal is reduced. Metal structure to be protected act as a cathode and is connected to the negative terminal of the battery. The inert metals like graphite, high silicon content, iron act as anode and is connected to positive terminal of the battery. When the DC potential is applied in the reverse direction to that of the corrosion current, it nullifies the corrosion reaction. So that the entire surface now acts as cathode and protect from the corrosion. So these are the methods adopted in order to protect the base metal. Along with this, we observe the two more kind of corrosion controlling method. That is a use of corrosion inhibitors. So while preparing or while manufacturing the metals or while carrying the metal finishing technique, we may improve the corrosion resistance properties by introducing a corrosion inhibitor that inhibit the rate of reaction, corrosion reaction. That may be an anodic inhibitor. By the addition of anodic inhibitor, we may reduce the anodic reaction, or we may introduce a cathodic inhibitor to the atmosphere. Then we can reduce the cathode reaction. The other method adopted to reduce the corrosion rate is by anodic protection. That is by converting the metal surface into anodic and introducing a particular potential which overcome the rate of reaction. Thereby we can able to protect the metal.